So you guys also need to know your derivatives of the 6 trig functions. So I'll write them all out for you. Sine, cosine, tangent. Derivative of sine is cosine x. Perfect. What about cosine? Negative sine x. What about tangent? Secant squared x. Perfect. Then let's do our reciprocal functions. We've got cosecant, secant, cotangent. Derivative of cosecant, it is negative. Cosecant times cotangent. What about secant? Secant tangent, perfect. So secant x, tangent x. And cotangent? It is negative. Cosecant squared. So it's super helpful. Notice the patterns. Remember I said that any one that the original function starts with a c, the derivative is going to be negative. So that's one helpful hint. Notice the pattern between them and it'll be a lot easier to help you memorize. So these you need to know for the quiz as well. For sure. Because the other 5 questions are going to be finding the derivatives of trig functions. So if you don't know the trig functions, that's half the quiz. That's 11.3. All right, let's look at number 5. So here we have 2 terms that we're multiplying. What would I need to do to find the derivative? Product rule. Our product rule is the first times the derivative of the second plus the second times the derivative of the first. So our first is 2x to the 5th power plus 3 times the derivative of the second. What's the derivative of cosine of x squared? Negative sine x squared. So what you're taking the trig function of stays the same when you write your derivative, but then we have to multiply it by the derivative of the, what we're taking the trig function of. So it would be 2x times 2x. All right, times the second, so cosine of x squared times the derivative of the first. What's the derivative of 2x to the 5th power plus 3? Awesome, 10x to the 4th power. I'm going to rewrite this to just make it a little bit easier, make a little bit more sense for us. So I've got a negative sign here. So I'm going to say negative 2x times 2x to the 5th power plus 3 times sine of x squared plus, I'll put the 10x to the 4th power first times the cosine of x squared. So this would be our derivative. If you want to distribute here, you can. You don't have to. Simplify to make it look like normal math. Like we wouldn't leave a negative sign in the middle of our terms that we're multiplying. So if you have like common factors, you can multiply them together. Like if I had another 5 here, I'd want to multiply that to the 2x. Wouldn't just leave things not multiplied. So simplify, but you don't need to distribute extra. You don't need to take out a GCF unless you notice that it's going to simplify more, which I'll show you in the next example. So 6, you could solve a couple different ways if you wanted to move it to the top. You could. I would leave it like this and just use quotient rule. So low, d high, low would be cosine of 2x cubed. The derivative of our numerator would be what? Negative 4x, perfect. So that would be low, d high, minus high, which would be negative 2x squared minus 5. D low, so our derivative of our denominator. What's the derivative of cosine? negative sine 2x cubed times the derivative of what we're taking the tangent or the trig function of. So what's the derivative of 2x cubed? 6x squared. Over what? Awesome. So cosine squared of 2x cubed. Which we could clean this up a lot. But this would be the gist of it. I would simplify it to negative 4x cosine of 2x cubed. I've got a negative here and a negative here, so that would turn to plus 6x squared. You can distribute if you want to, negative 2x squared minus 5 times sine of 2x cubed. Over cosine squared 2x cubed. Just because this was the original, like, it was like this in the beginning, so negative 2x squared minus 5. You could pull out a negative and change it to be minus. It doesn't help in simplifying anything else, so it would be okay this way. All right, let's look at number 8. So we have cosine of negative 3x squared plus 2 squared. So you could square, in all the other questions we squared our parentheses, because what's being squared is the negative 3x squared plus 2, not cosine. So you could square if you want to, but we would have to FOIL here, so that might be more work than what it actually is. So let's keep it like this. We'll take our trig function of the whole thing. So we'll take the derivative of the whole thing. What's the derivative of cosine? Negative sine of negative 3x squared plus 2 squared. Then times the derivative of this part. So that would be chain rule. 2 times negative 3x squared plus 2 to the first power times the derivative of the inside. What's the derivative of negative 3x squared plus 2? Negative 6x, perfect. So I would say this is 12x sine of, actually I'll put everything out front, 12x times negative 3x squared plus 2 times sine of negative 3x squared plus 2 squared. And then again here you could distribute. If you do distribute, this would give us negative 36x cubed plus 24x. Make sure you leave this in parentheses as well, because both of these terms are still being multiplied to the sine of negative 3x squared plus 2 squared. So if you do distribute, you need to keep those parentheses. What are we doing between e to the power of x and sine of x plus cosine x? We're multiplying, so let's use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be e to the power of x times the derivative of the second. Let's take the derivative of each term here since we're just adding it. Our derivative of sine would be what? Cosine x. Awesome. So minus sine x. We wouldn't say plus negative sine x. It would be minus sine x because our derivative would be negative. So first times the derivative of the second plus the second. So we've got sine of x plus cosine x times the derivative of the first. What's the derivative of e to the power of x? E to the power of x. How could I simplify here? Let's take out e to the power of x. We're left with cosine of x minus sine of x plus sine of x plus cosine of x. Does it simplify anymore? What cancels? The signs cancel. Negative sign plus sign would cancel each other out. What is cosine of x plus cosine of x? Awesome. So this would be times 2 cosine x. Or this would be okay, but we would probably put our coefficient out front. 2 times e to the power of x cosine of x. What should we do for 11? Product rule. So this is our first and our second. Here, is tangent being squared or just 6x? The 6x. So I'm going to distribute the squared to the 6x. We had one like this in the notes. Just to simplify, to make it easier for us to do the math. That way we won't have to do the chain rule inside the chain rule. So we have the tangent of 36x squared. So our first and our second. The first would be e to the power of 5x times the derivative of the second. What's the derivative of tangent? It would be secant squared. So secant squared times 36, or secant squared of 36x squared times the derivative of what we're taking the tangent of. What's the derivative of 36x squared? 72x, perfect. Plus the second, so tangent of 36x squared, times the derivative of the first. What's the derivative of e to the power of 5x? Awesome. E to the power of 5x times 5. So times the derivative of the exponent. We can write this a little bit neater. I already put the 72 out front. So 72x e to the power of 5x secant squared of 36x squared plus, I would just rewrite this out front. So 5 e to the power of 5x tangent of 36x squared. If you wanted to take out e to the power of 5x, you can. But it's not going to help us simplify any further, so you don't have to. So this is our derivative. What can we do for 13? You could move 5x to the top, and then what would we do? Product rule. Or if we wanted to leave it like this, we could use what? We could use quotient rule, right? Because we're dividing. I'll do it both ways for you guys. I'll let you be the judge. We'll do it both ways. So quotient rule is low d high. So 5x, what's the derivative of our numerator? So secant x tangent x. So low d high minus high, which is secant x, d low, what's the derivative of 5x? 5. So put that in front there. Over what? 25x squared. Can we simplify anything here? You could take out the secant, but it won't really help us with anything. What else simplifies? Do I have a common factor? A 5. I've got a 5 in both terms up top and a 5 from the bottom. So this would be x times secant x tangent x minus secant over 5x squared. So this would be our answer using quotient rule. Let's move it to the top and use product rule. So 5x to the power of -1 times secant x. Now be careful because 5 and x are moving to the top, so they both have the power of -1. So the first would be 5x to the power of -1 times the derivative of the second. What's the derivative of secant? Secant tangent. Plus the second secant times the derivative of the first. What's the derivative of 5x to the power of -1? Awesome. So this would be -1 times 5x to the power of -2 times what else? Times 5, because we have to take the derivative of the inside. So we can simplify this a little bit. This would be secant x tangent x over 5x plus, we have, actually this would be minus because it's negative, so minus 5 times secant x over 5x squared. Which we could simplify a little bit more. This would be 25x squared on the bottom. It would, so the 5 would cancel from 5 of the 25, so we're left with just secant x over 5x squared. How could I combine the fractions together? What do I need from adding or subtracting with fractions? A common denominator. So I'd have to multiply the first fraction by x over x. You don't have to combine them. Leaving it like this is fine. WebAssign took this as an answer, so I'll be okay with this as a quiz, on the quiz. Either one of these would be fine. But these are the same answer. One is just the fractions are together. If we were, in the blue one on the right, if we were to combine these together, we need a common denominator. So I'd multiply the top and the bottom here by x, which is why this one is x secant x tangent x. All right, let's do 14. Would I use product rule here? What do we think? Are we multiplying these two things together, the two x's? Are we multiplying? No, we're subtracting. So we don't use product rule here. We're just going to take the derivative of each one separately. What's the derivative of 3x? 3. And then we have -5 times cosine of 2x. So what's the derivative of cosine? Sine. So negative sign, perfect. So this would change to +5 times sine of 2x times what else? Times 2. Which we would want to rewrite this as 3 plus 10 sine of 2x. So this would be our derivative. All right, let's do 15. So same thing here, we are adding. So we're not using product rule, we're just going to take the derivative of each one of these separately. I'm going to change the square root of x to be x to what power? X to the 1/2 power, just to make our derivative a little bit easier for us. What's the derivative of x to the 1/2 power? (1/2x to the power of -1/2), perfect. Or we could rewrite this to be 1/2 times the square root of x. Just to move the x to the bottom since it has a negative exponent. Change it back to square root. So plus, now we're going to take the derivative here. Is cosecant being squared or 2x? 2x. So I'm going to distribute the squared. 2 squared is what? So we've got 4x squared here. So cosecant of 4x squared. That way we won't have to worry about doing the chain rule multiple times. So that 1/4 is just going to hang out front. What's the derivative of cosecant? Cosecant, cotangent. So cosecant of x, so our x value stays the same, of 4x squared, times cotangent of 4x squared, times the derivative of what we're taking the trig function of. So what's the derivative of 4x squared? 8x. Awesome. We can simplify this a little bit more. What is 1/4 times 8x? 2x. Awesome. So 2x times cosecant of 4x squared, cotangent of 4x squared. It should be negative cosecant. Yes, you are right. So this should be minus. I was just making sure you guys were paying attention. What do we have to do for 16? Product rule. Or if you wanted to, move the x squared to the bottom and do quotient rule. Up to you. But here, since it's already being multiplied, let's use product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x to the power of -2 times the derivative of the second. What's the derivative of tangent of 3x? Secant squared 3x times 3. Don't forget to take the derivative of what we're taking the trig function of. Plus the second, so tangent of 3x, times the derivative of the first. What's the derivative of x to the power of -2? -2x to the power of -3. Perfect. So we could rewrite this. We have 3 secant squared 3x over x squared plus, or actually this would be minus since it's -2. So -2 tangent of 3x over x cubed. I'm okay with you guys leaving it like this because WebAssign took it like this. But if we were to combine this together, what would we need? A common denominator. We'd need another x in our left fraction. So multiply the top and the bottom by x. So if you were to combine it together, again, you don't have to. This would be perfectly okay on the quiz. But if we were to combine it together, we'd have 3x times secant squared of 3x minus 2 times tangent of 3x over x cubed. So tangent of 3x, it was secant squared of 3x times the derivative of what we're taking the tangent of, which was 3. So our derivative here, the inside goes on the bottom, so sine of x. What's the derivative of sine of x? It would just be cosine of x. Bye, guys. So this would be cotangent of x, just to simplify. So first thing we should try with limits is what? Plug it in. Let's try direct substitution. So if I plug in pi over 6 here, I have pi over 6 times the secant of pi over 6. Let's find out what the secant of pi over 6 is. Secant tells us we look at what on the unit circle? 1 over x. Secant goes with cosine. Cosine tells us x, but secant is going to be 1 over x. So we're looking for 1 over x on the unit circle. Let's go to our unit circle. Secant of pi over 6 would be here. So 1 over x would be 1 over square root 3 over 2. How can we simplify this? Awesome. Keep, change, flip. When we flip the denominator, we get 2 over square root 3. So secant of pi over 6 is 2 over square root 3 times pi over 6. We can simplify here. 2 goes into 6 3 times. So we get pi over 3 square root 3. Could I leave my answer like this? No. What do we have to do? Rationalize. Let's multiply the top and the bottom by square root 3. We get square root 3 times pi, or pi square root 3 over what? 9. Awesome. So this would be our answer. Well, we did that. Square root 3 times square root 3 was 3, and then we still had another 3. So 3 times 3. Oh, yeah, just whatever your square root is. Because if you did the 3 to the top also, it would then simplify. Any questions here? All right, 22. We know that the sine of x over x is what? 1. So what do we do if we have the sine of x over 3x? What would this be? 1 over 3. Awesome. We look at the coefficient. So our coefficient of the x on top is 1 over 3 on the bottom. Let's say I had the limit as x approaches 0 of sine of 10x over, let's say, 3x. What would this be? 10 over 3. Awesome. Again, just look at the coefficients in front of the x's. All right, 25. What should we try first here? Plugging it in. Let's try that. So we have the tangent of 3 pi over 4. So going to our unit circle, 3 pi over 4 would be here. Tangent tells us we look at what? Sine over cosine, or in terms of x and y? Y over x. Tangent, we're looking at y over x. So our y is square root 2 over 2 over negative square root 2 over 2. What do we do to simplify here? Keep, change, flip, or we know that we're dividing by the same number, so it would just equal what? Negative 1. Perfect.
So when it comes to like tangent with anything under a 4, can you just put 1 or negative 1 depending on like the sign, or do you have to like actually solve it?
Just check your unit circle and then plug in. I mean, it's going to be that way whenever you have 4 in the denominator, but it's not always going to be 4 in the denominator. So our limit is negative 1. Let's do 26. What happens when we use direct substitution here? It's undefined. So what could we do? Awesome. We can change tangent to be sine of x over cosine of x over x. What do we do when we have a fraction and a fraction? Keep, change, flip. We're going to change to multiplication, flip to 1 over x. So then here we have sine of x over x times cosine of x. Do we notice anything here? Sine of x over x is 1. So I could split this up to the sine of x over x, which we know is 1, times what? 1 over cosine x. So sine of x over x, we use our formula, or the limit, as x approaches 0, sine of x over x is 1. And then what about 1 over cosine of x? When we use direct substitution, plug 0 in. What's the cosine of 0? 1. Let's look at our unit circle. Go to 0. The x value would be 1. So this would be 1 over 1. What's 1 times 1? 1. So our limit here would be 1. Also, one more thing I want to mention about 26. You could use L'Hopital's rule here. You don't have to. There's no question on the quiz where you have to use L'Hopital's rule, but it'll help you if you are stuck and you don't know. You don't have to use that for here, but one way that you could have solved is take the derivative of the top and the bottom and then use direct substitution.
So we don't have to use the rule at all?
You don't have to use it at all. It's not going to be thrown out for the test, so it'll come in handy in time for the test, but on the quiz, you won't have to use it at all. All right, let's do, Anya, you said 23? Let's look at 23. So if I plug in 0, what happens when we plug in 0 into our denominator? Tangent of 0 would be 0 over 1. So it gives us undefined. So let's simplify. Having sine of 2x tells us we're going to use our double angle formula here. So our double angle formula is 2 times the sine of x cosine of x over, since I'm changing everything to be in terms of sine and cosine, let's just do that for tangent as well. Tangent would be what? Sine of x over cosine of x. Perfect. So we can change flip, keep the top, change to multiplication, flip the bottom. So we've got cosine of x over sine of x. Sines are going to cancel. So we're left with 2 times cosine squared of x. Just cosine times cosine would be cosine squared. What should we try next? Substitution. Let's see if direct substitution works here. So if I plug in 0, cosine squared of 0, what's the cosine of 0? 1. 1 squared would be 1. And 1 times 2? 2. So our answer would be 2. So like the difference would be cosine squared of x or cosine x squared. Here, just the x is being squared. This one cosine squared. So this would be the same as saying cosine x squared. So you'd find what cosine of x is, then square it. This one, you'd square x, then find the cosine of that. So the double angle, if you have sine of 2x, double angle formula is 2 sine of x cosine of x. You need to know the derivatives 100% for sure. You need to know that the limit as x approaches 0 of sine of x over x equals what? 1. Perfect. Also knowing that tangent of x would be sine of x over cosine x. You need to know sine is y, cosine is x, tangent is y over x, and they're reciprocals. So cosecant would be 1 over y, secant is 1 over x, and cotangent would be x over y.